Now then, just to continue with the last three videos I've made, I'm going to have a look at the difference between hydrogen boilers and natural gas boilers, and whether hydrogen is better than natural gas or natural gas is better than hydrogen. Anyway, let's get on with it. Now, natural gas boilers have been around quite a while now. We converted from town's gas, which is coal gas or man-made gas, to natural gas in the late 1970s. So these boilers have been around quite a while, and they are a reliable, cheap way of heating our homes and hot water. But the downside of natural gas is it creates CO2. So it's putting carbon dioxide into our atmosphere, which is melting the polar ice caps and is making our polar bears very warm. And there's a lot of people around the world getting very fed up of it. So our government here in the UK is pushing for us to go into renewable energies and get rid of natural gas. The only problem with that is about 85% of the homes in the UK are heated by gas, which is about 23 million homes. So to use electricity, solar, air source heat pumps is going to be really hard to convert the house stock in the UK over to these green energies. But is there anything else we could use? The alternative to natural gas could be hydrogen. Hydrogen is the most abundant element in the known universe. On Earth, the vast majority of hydrogen molecules are made up in natural gas and water. There are almost no pure hydrogen atoms on this planet, and absolutely none of it is green or blue hydrogen. Hydrogen is a colourless, non-toxic gas which is highly explosive. Now, hydrogen has a lower explosive limits of gas in air in percentage of 4 to 75%, where natural gas has 5 to 15% gas in air as a lower explosive limit. So you can see hydrogen is far more explosive than natural gas. So that scares a lot of people. Now, I think the most famous accident with hydrogen was the Hindenburg disaster, where a German airship tried to dock in America in 1937, and hydrogen is said to have leaked into a walkway, and they created a spark and it blew up or set on fire the airship, killing a few people. I think it was about 13 people I think it killed. Anyway, I'll put down at the bottom how many it actually did kill. So that's one of the big problems with hydrogen, is people are already scared to death of it because they think it's so much more explosive than natural gas, which it is. But like natural gas, hydrogen is lighter than air, but it's 3.8 times lighter than natural gas, and it actually moves around the room 6 times faster than natural gas does. So bearing that in mind, even though the lower explosive limits of hydrogen are higher than natural gas, because it evacuates out of a room a lot quicker, 6 times quicker, then it's probably about as dangerous as natural gas is. Hydrogen also gives you a lot more bang for your buck. Now, hydrogen has about 120 to 142 megajoules per kilogram, and natural gas has between 50 and 55 megajoules per kilogram. So you can see hydrogen has nearly 3 times more energy in it, that's the megajoules, than natural gas. So you're going to use quite a lot less. But hold your horses there, cowboy. Because hydrogen is so much lighter or less dense than natural gas, they say you will need approximately 3 times the amount of hydrogen that you would do for natural gas to get the same amount of energy out of it. So they say to get the same bang for your buck with hydrogen to natural gas, we're either going to need to increase the pressure or increase the volumetric flow of the hydrogen to be able to get the same bang for your buck. Now, some people out there are saying hydrogen's mega expensive. Well, it's like everything else at the beginning. It is at the moment. But when the production starts, or they start to ramp up the production, then obviously this is going to start to come down the more people use it. Hydrogen can be made from natural gas or water. So depending upon what you're making the hydrogen from will depend on whether it's blue or green hydrogen. Now, making it from natural gas will make it blue hydrogen, and making it from water makes it green hydrogen. But the only problem again is, if we want to make pure green hydrogen, we're going to need copious amounts of electricity to be able to make it from water. Now, even though this blue hydrogen doesn't emit CO2 when the boiler's burning it, actually when you're making it, that creates CO2. It's called steam methane reforming, or SMR. And that process will create CO2. And then what do we do with the CO2? Well, basically they say they're going to bury it. That's, for me, that is not the way forward for making this planet green. I'm all for hydrogen because it's byproducts of hydrogen or water and oxygen. There's no carbon to make carbon dioxide or carbon monoxide. But we don't want to be removing the carbon dioxide and then burying it in our old mine shafts, do we? Because isn't there a chance of it leaking out? And then we're back to square one. We might as well just stay with natural gas. Now, when making blue hydrogen out of natural gas, we would actually use 1/3 more natural gas than we would do as if we were just burning it. That would actually increase our imports of natural gas by up to 10%. So really, blue hydrogen isn't the answer. And like I say, when the hydrogen is made from water, we need electrolysis. So like I say again, we need copious amounts of green electricity to be able to make this green hydrogen and not create CO2 in the process of making it. But whether they actually decide to make hydrogen from natural gas or from water, I think personally it is going to play a big part in reducing our CO2 emissions and making our homes heated and the hot water heated via green energy. So what's the difference between a hydrogen boiler and a natural gas boiler? Well, if you look at the box on the outside, absolutely nothing. They're going to look exactly the same and they are going to work virtually exactly the same. The only slight differences we're going to have is safety devices, how we're going to detect the flame when the flame goes out. That's the big difference, because the way we do it at the moment, we need the carbon to be able to make our safety devices work. Also, with natural gas having a nice blue flame when you burn it, when you burn hydrogen, it's colourless, it doesn't have a flame. So they're using silica to make it a orange colour. So for gas engineers in the UK, which we look purposely for a nice blue flame to say we've got complete combustion, that's going to go and we're going to have a nice orange flame, which doesn't kind of compute with most gas engineers at the moment, because for us an orange or yellow floppy flame is in complete combustion. So what they're going to do is, at the moment, or what they're suggesting is, we're going to have a blend of hydrogen put into the natural gas, and we're going to do it up to 20%. So if they do add this 20%, it's like taking 1 million cars off the road straight away. And if they do this 20% blend with the natural gas, it makes no difference to our boilers, cookers or fires at the moment, which are working off natural gas. If we do go higher than the 20% blend and we go up to 100% hydrogen, then that's where all our new gas appliances will come in. They have already sorted out hydrogen cookers, hydrogen fires and hydrogen boilers. They're already done, tested and approved. All the government needs to do now is throw a load of money into the infrastructure of hydrogen and get the natural gas lines brought up to be able to carry hydrogen, because hydrogen cannot be carried in a steel pipe. It needs to be carried into a plastic pipe. In the northwest, there's not a lot to do there because most of our mains now under the roads are plastic. So hydrogen can go through those quite easily. There just need to be a few modifications coming into the homes. So we would need, if we go to 100% hydrogen, we would need new gas meters, we would need new ECVs, we would need new anacondas, and we would need new boilers, cookers and fires to be able to work on this 100% hydrogen. Now our gas transporters will reckon we will go to 100% hydrogen by the middle 2040s. And that includes upgrading all the pipelines to take 100% hydrogen and training all the gas engineers over to be able to work on this hydrogen. So really, not long to get cracked on and get it done. Now, one of the downsides from hydrogen compared to natural gas is when you burn hydrogen, it produces water vapour. And it actually produces about 60% more water vapour than a natural gas condensing boiler does. So there's a big problem, isn't it? We're going to have all this condensate which will go down into our drainage system. But the thing is though, it's not going to have any carbon in it. So there's going to be no nastiness. So the good side of burning hydrogen, because it doesn't make carbon monoxide or carbon dioxide, is the safety aspect of it, other than it being more explosive. Because it doesn't produce carbon monoxide or carbon dioxide when you burn it, there should be no need for carbon monoxide alarms. We won't need them. Also, when engineers are commissioning these appliances, they won't need flue gas analyzers to be able to do the CO-CO2 and the ratio. We might have to use flue gas analyzers to make sure the combustion's correct, because we'll have to check the water and the oxygen levels, but flue gas analyzers will not be used neither. There's a thought. Not having to have them calibrated every year, and not having to look after them or get them nicked out of our vans, because they're a massive expense, flue gas analyzers. So hopefully they can come up with a cheaper option which just does the oxygen and the water vapour. There is a downside though to burning hydrogen, and that's nitrogen oxide, or NOx as we call it in the gas industry. It is said that a hydrogen boiler will produce about 6 times more nitrogen oxide than a boiler burning natural gas, which is not very good for us, is it? So there's always a downside to everything. Are we going to save the polar bears? Or are we going to kill ourselves off? Now let's have a look at the pros and cons of hydrogen compared to natural gas. So we'll start with the pros first. So the first one, familiar technology. Now there's not going to be much needed to change over from natural gas to hydrogen boilers, especially where the production of the boilers comes in. Still going to be kind of the same production line. So there's not going to be much changed in that way. We've got low disruption. So for the customers, you're taking out a natural gas boiler and you're putting a hydrogen boiler in, so it's still got the same pipework, it's still got the same radiators, so there's not going to be much disruption, unlike if you were going to change it to an air source heat pump where there's massive disruption. Reasonable upfront costs. So again, to change over from natural gas to hydrogen, the boilers are going to be around about the same, and they reckon, alright, hydrogen's more expensive, but it's going to be round about the same. Unlike again, if you're changing to air source heat pumps, the upfront costs are massive. It can heat a poorly insulated house, so this is pretty much the same as a natural gas. So a natural gas boiler, you can't believe how good they are. When they're gone, everybody's going to miss them because they are so good at heating people's houses very, very quickly. And so will hydrogen boilers. They will still heat very inefficient homes. Again, unlike an air source heat pump. It doesn't make any CO2 or CO, so it's safer, technically, more than natural gas, because when it's burning, it's basically creating water vapour. So no CO, no CO2, so it makes it much more safer, kind of. Let's have a look at the cons. Most hydrogen production isn't carbon free. That's the biggest downside for hydrogen, the way we're going to make it, because it's not naturally formed in the planet like natural gas is. So we're going to have to make it, and if we don't get our electricity 100% green when we're making green hydrogen, then we're going to be making blue hydrogen, which is made out of natural gas, which means we need to hide the CO2, and it means we need 3 times the amount of natural gas. So that's a big con for it. Now, one of the things you don't get heard a lot of, it makes nitrogen oxide. So that's going to be a big problem for us if it does make these high levels of nitrogen oxide, because it's quite poisonous to us. Running costs are likely to be higher than natural gas, because the gas is going to be more expensive, so they say. But the way the gas prices are going up anyway, how can they say that? It's if buts or maybes. Now then, the biggest one, highly flammable. Now it's a lot more flammable than natural gas. So again, something we need to be really wary of. But this one is a big one as well, because the molecules are so tiny. They are the smallest molecules of any component on the periodic table, so they tell me. When it's leaking, it's going to be hard to detect, unlike natural gas, because it is lighter, it is smaller, it's going to be really hard to detect. One of the other things as well is we can't have the general public playing around with hydrogen. Unlike lots of people, because I see this on my videos all the time, I can do whatever I want in my house, I can play with my gas. You ain't going to be playing around with hydrogen, because it will find the smallest place to leak out of. And again, this could be a problem with our national grid, because we have a big leakage of natural gas through our production of the natural gas and getting it to the houses. The storage places leak massively, and the distribution pipework leaks massively. So if we've got a massive amount of hydrogen leaking out, then we could be getting some explosions. That for me is the biggest con. Actually, the small molecules being able to leak out anywhere, and people playing around with their own gas appliances or trying to fit their own gas appliances without actually testing the system. So that's for me the pros and cons of hydrogen compared to natural gas. So if you want to see any more of my videos, you can catch it here. Thanks for watching. Cheers.